All right, so we're going to talk about even degreed polynomials. In an even degreed polynomial, how do you determine what the degree of a polynomial is? Exponent, yeah. You take the highest exponent in there. So the degree of a polynomial is its highest exponent in it. Again, understanding that a polynomial equation is an equation that has all exponents are non-negative integers. So now, if the leading coefficient is positive, the graph starts high and ends high. If the leading coefficient is negative, the graph starts low and ends low. All right, so let's go back to this polynomial y equals x squared. Now, this is the correct graph for y equals x squared. This is the correct graph for y equals x squared minus 1. What is the leading coefficient in each one of those? Positive 1. Positive 1 is the leading coefficient in each one of these. And it's even degreed because the highest exponent in both of them are 2. Now, to take on just a little bit of a different outlook on it, I want you to consider this. In the past, we've described this as opening up. And that is true. The graph opens up. But another way to look at opening up is to say this graph is going to start over here high up, and then it's going to come down, and then it's going to curve around, and it's going to end up high. So that's what I mean by starts high and ends high. Now, another graph we can look at is y equals negative x squared. Well, y equals negative x squared. In the past, if I'd asked you to graph this, you'd say, okay, its vertex is at the origin and it opens down. Well, opening down is another way of saying the graph starts low and ends low. It starts low, comes up here, and then it ends low. So starts low and ends low is, again, equivalent to saying that the graph opens downward. Now, in a parabola, it's easier to think about it at opening up and opening down, but we'll have some even degree polynomials that will do something along the lines of this. So that's not, it's a little bit different to think about that as opening up, but you think about it as it starts high and then it ends high. Doesn't matter what it does in here, it's just going to start up high and it's going to end up high. All right? So we've discussed a little bit with even degreed polynomials. Now let's think about odd degreed polynomials. Odd degree polynomials. Odd degree polynomials, of course, have an odd exponent associated with the highest exponent in the problem. Now, again referring to the leading coefficients, if the leading coefficient is positive, you can write that down. If the leading coefficient is positive, then the graph starts low and ends high. If the leading coefficient is negative, then the graph starts high, and ends low. All right, now, usually when we describe the graph of a line, we don't describe, or just a line equation in general, we don't really call it a polynomial equation, but it is. So let's think about this. What is the highest exponent associated with each one of these equations? 1, yeah. And 1 is an odd integer, so we have an odd degree polynomial. All right, well, what is the leading coefficient in the case of y equals negative 2x plus 1? Negative 2. Negative 2 is the leading coefficient here. So what are we seeing here? Well, we're seeing we've got a negative leading coefficient. The graph should start high and end low. Well, what does it do? It starts up here high, right? And it comes down and ends here low. Going left to right. It drops. Likewise, what's the leading coefficient in y equals x plus 4? 1, and 1 is positive, right? It's still an odd degree polynomial. So, positive leading coefficient, the graph starts low and ends high. So what's happening here? We start low and we end high. So that's an overall theme that goes along with what we're referring to here. Any question through this? All right. Now, the next thing we're going to talk about, and this may be new to you, but we're going to talk about multiplicity. Multiplicity. The multiplicity of a root, and I'm not going to write this down, but the multiplicity of a root is the exponent of the factor associated with the root. The multiplicity of a root is the exponent of the factor associated with the root. Does everybody have that, or do I need to repeat it? good? Okay. All right, everybody's good? All right. So, and when I say root, understand root is synonymous with 0, synonymous with solution, synonymous with x-intercept. All these terms mean the same thing. The root, the 0, the solution, the x-intercept, those are all the same concept right here. So, if a root's multiplicity is odd, then the graph crosses the x-axis at that root. If a root's multiplicity is odd, then the graph crosses the x-axis at that root. If a root's multiplicity is even, then the graph touches the x-axis at that root and turns away. Okay, so I'm going to take the first examples that I did, the examples that are over here, and I'm going to tie those in with what I'm just now talking about. I've got y equals x squared. All right, I broke x squared down into x plus 0 squared. X plus 0 is the factor there. What exponent is associated with that factor? 2. So that means that 2 is its multiplicity. And 2 is an even number. So it says, if a root's multiplicity is even, then the graph touches the x-axis at that root and turns away. What's happening? The graph comes here, it touches at the origin, and then it turns away. It goes back. All right, now, let's look at y equals x squared minus 1. All right, we know the graph of this just from a previous lesson. It takes the graph of y equals x squared, it drops it down 1 unit. This is the correct graph, but let's analyze it a little deeper. How does x squared minus 1 factor? It factors into x plus 1 times x minus 1, right? Okay, so that is in factored form. So my roots here are x equals -1 and x equals +1. What exponent is associated with each one of those? 1, right? And 1 is odd or even? Odd. So if a root's multiplicity is odd, then the graph crosses, and I misspelled crosses, the x-axis at that root. What's happening here at -1? We cross the x-axis there, right? What happens at positive 1? We cross the x-axis there. So it works. It works in problems that we've known how to graph in the past. It's just we're breaking it down and analyzing it a little bit more. It even works on this. If this is my root, if I set that equal to 0, 0 equals negative 2x plus 1, then that means that 2x equals 1, so x equals 1/2. Well, this is an odd multiplicity because it's to the first power. Here's 1/2, that's my root, and that's where it crosses the x-axis. Likewise, this would cross at x equals negative 4. It's associated with the root, the factor x plus 4, odd multiplicity. We're crossing the x-axis at that value. So it all ties in here together. All right, now we're going to look at some examples that are actually going to take a little bit more work. So, and there are 3 examples we're going to look at, and each one of them is going to take a little bit of time. And each one of them has a little bit of a different twist to it. So, let's consider the first one. And it's going to be y equals x cubed minus 4x squared plus 4x. All right. Now, let's talk about the basics for the first part of it. The first part of it, I'm going to be referring to everything through multiplicity. This is an odd or even degree polynomial. Which one? Odd. It's an odd degree polynomial. Okay. Leading coefficient is positive or negative? Positive, right? It's positive 1. So what's the first thing I know about this graph? It's an odd degree polynomial. Leading coefficient is positive. Odd degree polynomial, leading coefficient is positive. This graph is going to start low and end high. So I'm just going to kind of jot that off to the side. When I graph it, I know it's going to start low and end high. All right. Any question about that? Now, this is the next part's the part that's just a little bit more involved. We've got to go about factoring this graph out. So, how can we factor x cubed minus 4x squared plus 4x? Well, what's in common with every term? X, right? So let's pull an x out. So I've got y equals x times x squared minus 4x plus 4. All right, now let's look at factoring that out. How does that trinomial factor? Two things that multiply to give me positive 4, but add to give me negative 4. Minus 2 and minus 2, right? And how can we rewrite that? That's also the same thing as y equals x times x minus 2 squared. Are we okay with this? All right. So, I've got it in factored form. Now I need to start dealing with the multiplicity. All right, my two roots are x equals 0 and x equals 2, right? Okay. What is the multiplicity associated with x equals 0? Starts with a W. 1. That's correct. So This has a multiplicity of 1. So what do we know is happening here? We're going to cross. All right? Now, what is the multiplicity associated with the root of 2? 2, yeah. Here's my exponent, right? I've got this as my exponent, so this is my multiplicity. So what am I going to do at 2? If the multiplicity is even, then I touch the x-axis and turn away. So I'm going to touch and turn. Now these are terms that are going to be used when you do your homework. You're going to use, it's going to say crosses or touches and turns. So just be used to that. All right. So let's start doing what we know here as far as a graph is concerned. Okay. I have intercepts at 0 and 2. So here's 0, here's 2. And I need to go up. I'm going to start low and end high. So I'm going to start down here and I'm going to end up here. Starting here and ending here. When I get to 0, that's going to be the first intercept I cross. What am I going to do? I'm going to cross the axis there. Now, when I get to 2, I need to touch and turn away. So I'm going to come back, I'm going to have to loop down, then I'm going to touch and turn away there. So that is what that graph is going to look like. Another term for that touching and turning away, since it's a multiplicity of 2, we can also call that a double root. So you may hear that term from time to time, called a double root. Okay. Are we good to keep going? Mm-hmm. All right. So, next example. Y equals x cubed plus 3x squared minus 16x minus 48. All right, now, in factoring this one, since we have not done synthetic division yet, in factoring this one here, we're going to need to use a strategy called factoring by grouping. When y'all took the state algebra 1 test many, many years ago, you had to be able to factor by grouping. But it's just not something you use that often. But what factoring by grouping does is it has us pair them up, and typically the best pairs that work are grouping the first 2 together and the last 2 together if they're written in descending order. Okay, so I group the first terms together and the last terms together. From the first pair of numbers, what factor do you see in common? X squared, right? Okay, so I'm going to factor out an x squared. And when I factor out an x squared, what am I left with? Just x plus 3. All right? Now, in the next parentheses, what do I have in common? Negative 16, yeah. And when I'm done that, what am I left with? X plus 3. I keep dinging up here. Every time I write something up on the board correct, I ding. Or maybe that's because someone's answering me. Okay. Now, what's in common with both places right here? This is a binomial. I've got an x plus 3 in common with both places, right? So I can turn this into x plus 3 times x squared minus 16. And how does that factor? X plus 3 times x plus 4 and x minus 4, right? All right, so my roots here are x equals negative 3, x equals negative 4, and x equals positive 4. What is the multiplicity associated with each one of those roots? 1. So what's going to happen to our graph on each one of these? We're going to cross, right? We have all odd multiplicities. So every time I hit one of my values, I'm going to cross there. Leading coefficient here is positive 1. It's odd degree. So I also know that I'm going to start low and end high. So here we go. Graphing it out. I'm popular. All right. Now there's one other thing that's happening here. I also have a y-intercept of negative 48 in this case. So that's going to be way down here. Okay, so I go back 4, back 3, and over 4. So I cross at each one. So I'm going to cross here, then I'm going to cross here, then I'm going to go down to negative 48, and then I'm going to cross back here. So this graph is going to take on some kind of shape, and I totally missed that mark. It's going to do like that. So that's what that graph is going to resemble. Any question there? Alrighty, we got one last example to go. Y'all are fast listeners. Now the next one I'm going to give you is already going to start out in factored form. So we're going to look at y equals negative 4 times x minus 3 to the third times x plus 1. All right. Now, this problem right here is already in factored form. The other problems just started off as the polynomial itself, and then we factored it. But this is starting out in factored form, and I don't want to sit here, cube this binomial, then distribute negative 4 into it, and then distribute x plus 1 into it. That's a lot of work. So I can still come up with the information that I need. First bit of information is the leading coefficient. The leading coefficient, and this is where you need to pay careful attention. The leading coefficient comes from the first terms everywhere. So this is -4, all right? This is x cubed, because this cube out here, and this is x to the first. So I've got -4 times x cubed times x. So what does that make my whole leading term? When I do this arithmetic, -4 times x cubed times x. And a few of you accidentally have your cell phones out, so you may want to put them away. All right, so we've got -4x to the fourth, correct? All right. Now, that means from this, leading coefficient is negative, and the degree of this polynomial is 4, which is even, yes. So, even degree polynomial, leading coefficient is negative, so this graph is going to start low and end low. What are my roots? X equals 3 and x equals -1. Those are my roots. Both of these roots have odd multiplicities. So for that, we're going to cross the x-axis at each one of those locations. All right, so let's start our graph. Okay, so I'm going to go back 1 and then to the right 3. Now, there's one other thing happening here. The y-intercept for this graph I would get by multiplying all my last terms together. But I've also got to use the -4. So my y-intercept is going to be -4 times -3 cubed times 1. -3 cubed is 27, -27, sorry. And -27 times -4 is positive 108. So I've got an intercept here of positive 108. That's way up here. It's me exaggerating. I don't really know where it is. But anyway, we're going to call this 108. That looks like a good place to put 108. Okay, so we're going to start low. I said we end high, but
Doesn't it start low?
it ends low, yeah. Starts low and ends low. Because it's even degree. Okay. So I'm going to cross at -1. And then I'm going to go up here all the way to 108. And then I'm going to come down. Now, if this was just a 1, it would just cut straight through. But it's 3, so it's actually going to bend here when it crosses. Now, the explanation behind that has to do with calculus, and we're not going to get into calculus in here. But that graph is going to take on that shape right there. So, we covered a good bit in here. Going back and looking at this video again may help. Again, it's under my channel, and I'll just title it Multiplicity Graphs. I guess that's a good name for it. Yes?
What